In 7.2, we're going to learn how to add rational numbers. So when adding rational numbers, we follow the same rules that we did when we were working with integers in chapter 1. So let's do one example where both numbers are fractions, but one is a negative number. So let's do negative 8/3 plus 5/6. Okay, and we know when doing fractions, we need to have a common denominator. So I'm going to change my negative 8/3 to a 6 by multiplying the top and bottom by 2. So I'm going to get negative 16/6 plus 5/6. Okay, and I now have a negative number and a positive number. And I learned in chapter 1 that if the signs are different, I subtract and keep the sign of the larger absolute value. So I'm going to take negative 6 plus 5. So I'm really going to subtract. I'm really going to do really going to do 16 minus 5. And I'm going to get 11. And then I'm going to have, again, I'm going to keep this negative sign because this is the larger number. So I'm going to have negative 11/6. Now, I can put that into a mixed number to make it look a little bit better. So 6 goes in 11 one time with 5 left over. So I'm going to really have negative 1 and 5/6. So that's how you do rational numbers that are fractions. Again, you follow your fraction rules by finding that common denominator. Okay, in this case, it was 6. I follow the rules I learned about integers in chapter 1, about the negative and the positive, and because they're different signs, I find the difference, but I keep the sign of the larger absolute value. Okay, so that is how we do adding rational numbers. I'm going to give you another example. Okay, now let's do some decimals. I'm going to do negative 12.5 plus 15.3. Now, again, I have opposite signs. I have a negative 12.5 and a positive 15.3. And because the signs are different, I find the difference. Remember, different means difference. Difference means subtract. Okay, 15.3 is the larger absolute value, so I'm actually going to put these vertically. It's much easier to put these vertically, so I can line up my decimals. You must line up your decimals, okay? And this is really a positive 15.3 and a negative 12.5, so I can just subtract if I want, okay? So I'm going to borrow and make that 13. 13 minus 5 is 8. I'm going to make that a 4, and I'm going to make that a 2. I'm going to get 2.8. Now, I have to go back up to the very beginning and really look at which one was positive and which one was negative. I need to make sure that my number is correct. This was my positive, and this was my negative. And if they're different signs, I find the difference and keep the sign of the larger absolute value. Well, this is my larger absolute value, so I'm going to keep that sign. So my actual answer is 2.8. Remember, there's that invisible plus sign in front of it that you don't need. There's one more thing that this chapter, or this section of chapter 2 wants us to do, and that's evaluating expressions. They want us to evaluate 2x plus y when x equals 1/4 and y equals negative 3/2. Okay, so all we're doing is we're going to plug this x and this y into this equation. So I'm going to have 2 times 1/4 plus a negative 3/2. Does that make sense? So 2 times 1/4 is, remember, there's that invisible math. And when I multiply fractions, I just go across, so I get 2/4, which is really 1/2, right? Because I can simplify this and divide it by a 2. Okay, so I have 1/2 plus a negative 3/2. They're opposite signs, so I'm going to subtract. Okay, so 3 minus 1 is 2, right? Because this is my bigger absolute value. So I'm going to do 3 minus 1, and I'm going to get 2. Okay, but I had to keep the sign of the bigger number. The bigger number is, or the bigger absolute value is this negative 3. So I'm going to make that a negative 2. So I get a negative 2 over 2, which is really just negative 1. Right? Because 2 can come out of that and get 1, and 2 can come out of that and get 1. So I get negative 1 as my answer. So to recap, when given an expression and they tell you what x and y are, all you do is plug those into your expression, and then you just solve, simplify, and then you get your answer.